Hey folks, Ms. Gosling here. In this video, you are going to learn about solar power. By the end of the video, you'll be able to quantitatively analyze the energy provided by solar panels. So let's go ahead and get started. So solar panel is any time that we convert the heat energy in the sun into electricity. And perhaps a little bit more accurately, rather than heat energy, let's call it the electromagnetic energy. So the electromagnetic radiation from the sun into electricity. So we have two key kinds of solar panels. The first is something called a solar heating panel, which uses the heat of the sun directly to heat up water. So this is something that you might use to replace kind of a traditional water heater in your house. So if you need hot water for a shower or for washing dishes, or for washing your hands, you could use a solar heating panel rather than a traditional water boiler to keep that water heated up. The more traditional, when you think of solar panels, though, usually what you think of are photovoltaic cells, which convert sunlight into electrical energy. And what they're doing there is they're using the kind of electrochemical nature of the materials that they're made out of to generate, to use the sunlight, the energy from that sunlight, and to convert that into electrical energy and to generate a current. So some pros of solar panels. They have low maintenance costs, no fuel cost, they're renewable, they do not exacerbate climate change. And one thing that's really cool is they can be used by individual households. So if you want a solar panel, you can go out and put it on your house. If you have a cheaper calculator, so like a lot of your kind of like the four function calculator to the scientific calculators that you use in elementary school, a lot of those are also powered by solar panels. Some cons though, their installation cost is very high and can be cost prohibitive for people who might otherwise be interested in solar panels. They can be inefficient, so you need a lot of solar cells in order to generate a usable amount of energy. And the energy output is variable, dependent on the season and the weather. So, for example, if you live here in Virginia, you're going to generate a lot more energy in the summer than you would in the winter, just simply because we have more daylight hours in the summer than we do in the winter. So the math for solar panels is really, really simple. So the power, let me go ahead and write that in yellow like I've been doing for some of the other videos. So the power generated by a solar panel is equal to the efficiency. And in this case, this is actually the efficiency as a decimal rather than as a percentage. So, 45%. So instead of being 45%, we're going to multiply by 0.45. So anyway, we have our power output is going to be our efficiency times the intensity of sunlight times the area of the solar panels. So let's go ahead and look at an example. A house requires an average power of 4 kilowatts to heat water. The average solar intensity of the Earth's surface is 650 watts per meter squared, and the efficiency of the solar heating panel is 20%. What is the minimum surface area of panel needed? So our givens here are the power output, which is 4 kilowatts, the intensity, or 4 times 10 to the third watts, the intensity, which is 650 watts per meter squared, and the efficiency eta, which is 0.2, or 20%. The unknown here, and guys, you'll notice I'm writing eta as a decimal instead of as a percentage. So our unknown here, guys, is going to be our area. And I know that the equation that relates all of these factors is the one we just discussed. P equals eta times intensity times area. So my area is going to be equal to my power needed divided by eta times my intensity. And now I'm ready to sub and solve. So the area of solar panels needed is going to be given by my power, or 4,000 watts, divided by eta times my intensity of 650 watts. Thus, I need approximately 31 square meters of solar panel to heat the net needed amount of water. So let's go ahead and talk takeaways. First of all, solar panels are renewable and do not generate greenhouse gases. They can be used to heat, so we have two kinds of solar panels. We have solar heating panels, which heat water, while photovoltaic cells generate electricity. And finally, the power generated by a solar panel is dependent on the intensity of sunlight, the area of the solar panel, and the solar panel's efficiency. So now you know how to solve solar power problems. It is your turn to try some out on your own. Best of luck and happy solving.